Hello student, this clips is the next clips from what we talking about the properties of the material in our civil engineering. The first one we talking about the steel, and then the second one we talking about the concrete. Okay, for the concrete, before we go next to the third clips for the timber, let us talking a little bit about the new coming technology that may change the way we work in our civil engineering, and is also involved with the material that we are going to use. Let us consider this picture. It's just a model. They're talking about how we use the robot, how we use the print 3D, 4D to build the new structure. Is this impossible? This is possible? This is very possible. Okay, in the past it may not possible due to the technology is not ready yet. But today we have high technology about the robot. We can build the robot. We can do the programming of the robot following our construction procedure. And now the important thing is about the material that's going to use in this construction. Is this going to be the concrete? If it's going to be the concrete, it's going to be a special type of concrete that's supposed to be hardened really quicker than what we have nowadays. And it's maybe any kind of composite material that is durable, that is safe for our life. Yes, it's maybe. Research is in need for development of the material that's appropriate from this kind of construction. For the pattern of construction, if we talking about in Thai, we're going to leave what so-called beam column structural system. Change to what? Change from the beam column, okay, structural system to what so-called load bearing wall. Okay, that's this mean we will not need to have the beam and the column. The floor will connect to the wall directly, not the floor connect to the beam, transfer the beam to the column as we have. And this kind of load bearing wall have been used in the Western country for many times. They didn't use much the beam column structural system, such as we have in our Southeast Asia. And sure, it will come since we have the problem about the quality worker. Okay, because the worker nowadays, most of them come from for a neighboring country, and I don't think I think when their country develop and have good enough quality of life, and I'm pretty sure they're going to go back home and they won't stay in Thailand. And the same as your country. Okay, so this is a kind of introduction to the new kind of what the way we are thinking about the work for our civil engineering in the future. And this also involving the robot in the construction in the future. We don't need to have a quality mason. We may have just the robot that can rearrange the brick and construct the brick wall beautifully, and going to be sure in the near coming future. Next material that we are going to talk about the timber, and you know that the timber, that's the kind of wood, and that is natural material in our old days. The timber in Thailand, in Laos, Cambodia, we have a lot of timber, and due to the change in our globalization, okay, the timber just kind of now is kind of expensive material. It's not cheap, it's expensive material. Last 100 years ago, only normal people have timber house, and only rich people have the reinforced concrete house. Things are going opposite. Nowadays, only rich people have a big timber house, and normal people living in the reinforced concrete small house. Okay, and new thing that I like you to go to search from the Google is going to introduce you with the commercial forest. If you guys have land and then you have knowledge of planting forests, you may do this kind of thing, and you may come to some kind of engineering stuff about timber that's called the gulam. Okay, that is laminated lumber, gulam. Okay, that is going to be glue. It's come from glue plus lumber. Okay, usually in the Western they have the commercial forest. They cut a small piece of wood and then they connect that wood with very special glue, and they can build a bigger portion of the timber. Okay, that's called is a gulam, and that is a kind of new thing that you guys may have in the coming future. Okay, let us coming to this. In the past century, the timber is the main construction material that we have in Thailand or in Asia. However, nowadays good timber is rare, very high quality. Let's say the high quality. Okay, it's rare and it's very expensive due to the forestation that we know. The steel and concrete are developed in the past 100 years and are becoming the main construction material in our civil engineering application. Okay, the use of timber is kind of rarer and rarer and only for the luxury building. Okay, that's can have this kind of big scale timber to build on. Anyway, I propose you guys to consider some new concept about the conversion forest, about the gulam, those kind of new engineering stuff. Back to the old day, the timber have been used in the palace, like this one in India is Hawan Mahal. That is very big timber palace, and it's built with the timber and the brick. And also the Forbidden City in China that's built the timber structure. The whole timber structure here is very large, built on the stone foundation. Okay, and this past like 100 years, and because of the good maintenance, this kind of palace and structure have attract a lot of traveler coming to India, coming to China, and produce a lot of money for this business. And also in Myanmar, in Burma, in Myanmar, is Mandalay Palace also. This palace is one of very beautiful palace. Okay, and it's destroyed during the World War II when Japanese bombed this palace. However, due to very rich forest in Myanmar, the palace can be restored to its original condition, and it's really beautiful. I didn't have the chance to go here, but my wife she visited there and she says it's really gorgeous, very beautiful timber structure. When you grow the timber will go years by year, and for the commercial forest, they're going to have some kind of control environment. For example, they're going to cut the tree for every 10 years, something like that. When it's cut the timber, and then you may see the cross section of timber look like this, and there are some important parts like the bark, that is the outer layer of the timber, and you have the cambium layer That is for the growing layer of the timber. Each year, the Cambrian terrier will make what's so called the annuling. Okay, that's so called the annuling. Okay, annuling is here. Okay, it is the ring of the sapwood and the hardwood that go up from the Cambrian layer. The sapwood and the hardwood are the real portion of the timber that we use. The sapwood is outer part of the hardwood. And actually, when we cut the timber, okay, we cut timber going to be something like this. We just cut to this point, and we're going to have the big timber like this. This can be the portion of the column. Okay, it can be rectangular or it can be square. That's built for the beam. Okay, from the column. If you like to build the beam, you may cut like this. Okay, that is going to be 2 beams. And if you cut it in small like this, that is going to be the plank, P-L-A-N-K, the plank, the wood plank that can be used for the floor of the house. Okay, so it depends on how you cut the timber. Okay, and most of the timber come from the sapwood. That is correcting neutral layer of timber, and the hardwood, that is the darkest layer of timber, and the songket and more durable layer of the timber. Okay, and you also need to consider the defect of the timber on the lumber. Okay, lumber is a part of timber. Like I said, if you put the first portion, that's idle, that's timber, and then you cut to parts lumber. There are some defects that's going to impact, okay, the strength, durability, and uses of the timber. Some causing this kind of defect, bow, this kind of defect, or crook, or twist, or cup. This happen when you cut the wood and you didn't do good maintenance or caring of it. Most wood are wet. Fresh wood are wet. Fresh wood are wet. It's wet. Okay, it may have the percent of water inside the wood up to like a 30%. So when you get the fresh wood, you got to dye it. Okay, and usually you got to dye it naturally. If you have a good dyer controlling by the computer, like in the Western country, that's also the good one. But you need to research it to dye the wood, to dye the timber in a good manner. Okay, so this is going to be bad because it's going to make our timber structure different from what we have in our theory. Such as if this is going to be the beam, okay, this beam going to be is a crooked beam. That's going to be crooked beam. Okay, that is no good. And also, this kind of thing you're going to consider is a defect due to its own natural material, such as the check. Okay, the check. Check is the crack like this. That's occur. Is the longitude cracks that occur causing the annuling. Okay, this is due to the non-uniform dryness of the timber. And also it has the crack here is called check. Check is parallel grain crack. And it has the vein, that is the good. This is not good cut of the timber. It's cut near the bark, and that is going to be the weak portion of the timber, because the timber, when it's near the bark, the strength of the timber is going to be lower than the one that's in the core or the hardwood or the sapwood of the water. The timber is kind of orthotopic material, which is different from the steel. The steel, we call the steel is the homogeneous, OUS, and isotopic, okay, material. That is for the steel material, okay, material IAL, the steel. Why? the steel, if you have a piece of steel and if you point out to any point, okay, of the steel, you will find that every point of the steel, they are the same. But the timber have the grain, okay, along its length, like this one. It's have the one that's parallel to this, and that's timber passing to what's so called the annealing of the timber. So if you pinpoint like this, like this, like this, the timber may not have the same thing. So actually the timber also kind of non-homogeneous material. Okay, and for the isotopic, for the steel, you can cut the steel in this direction and you test it, and you cut the steel in this direction, you cut it, you test it. The property that you obtain from the test going to be the same, but the wood won't be like that. If you cut the wood, follow the grain, that is going to be parallel to the grain, the property going to be something. And if you cut it in the perpendicular to the grain and test it, the property going to be different. And the timber have different mechanical property in the perpendicular axis, in the longitudinal, in radius, and in the circumferential. But usually the radius and the circumferential provide very close mechanical property of the timber. So mainly we consider timber one parallel to grain, okay, and another one perpendicular to grain, and the behavior are different. Mostly when it's parallel to grain, the force, the applied force, gonna take by the grain, and then the behavior of the timber is a kind of brittle. When you apply the force parallel to grain, okay, not only the grain, or also the timber layer taking care of the force. So the behavior of this timber in this direction is in the ductile material. Recall what we have in the lab. Okay, in the lab we also have the compression test of the timber in the direction parallel to grain. Okay, we have the lab in compression like this, and also we have the lab that we have the timber, but this time we lay the timber in this direction. Okay, and then it have the grain like this. Yes, the grain like this, and then we apply the force into this. This is up to the application of we have. For this is kind of the column, okay, that's subjected to the force along the grain. But this one may have be something that's to support, like to support. This can be used to support the railway. Okay, the railway. Usually, it's railway. In the old time, they used the wood to support the steel. It's going to be something like this. And the usefulness of it is what? It's going to be like a soffit. They are soffits to the beam. So you have the steel, and you push the steel in this wood. Okay, it's going to be the railway, and this wood is going to be contact to the soil layer, and then you have the cut stone around here. So this kind of going to be a soffit. Okay, that's help protect the steel railway from the environmental. Also, it is a kind of a spring. Okay, spring to take care of the load from the train. And you also have this one for supporting large structure also. When you protect like between the concrete and concrete, you may put the timber between them. so the concrete won't crush each other. Okay, and also in the lab, you also do the test like what? Like this. This is the test for the shear. Okay, you put the timber into the steel case, and then that's going to lock the this specimen, and then you apply the force into this. What we have is you're going to shear this specimen by this. This you testing for the shear. You determine the tau max that is going to take. Okay, that is another thing. We need some tests. Also, we have the test for the beam. We have many tests for the timber. We have the 3-point loading for the beam, for the long one, and then you apply the force here. The beam gonna have some crack. Okay, the crack maybe occur part in here in tension, or some may occur in this for compression. And you also have a short the beam. Okay, short the beam when you test it in the lab. Okay, that is what we have in our laboratory. That is going to produce the difference in the mechanical property, because the mechanical property of timber depend on the direction of the force, parallel to grain or perpendicular to the grain. Okay, and timber, when it's subjected to the load, that's parallel to the grain. Okay, that's I mentioned before, and you may have the graph that's going to be like this. It's going to grow up like this, and within the point B, that's behavior of this one is still what's so-called the linear. Okay, elastic. Usually, we find the point P. The point P is going to be sigma sub proportion, and we use this as the strength of the timber comparable to the yielding strength of the steel. Okay, but after this point, the timber have very small portion of deformation. Okay, only this. So the behavior of this is so-called brittle. After reaching the proportional limit, the timber still only have very small deformation and fail. However, if you test it perpendicular to the, the grain, okay, what we have is the same thing, but this time the material can take, okay, more, can show more deformation, because under the application of force parallel to the grain, okay, not only the grain that's taking the force, okay, this one, after reaching this, and then the grain start to fail, and then the structure fail abruptly, because when it's parallel to the grain, most of the force taking by the grain. But for this one, perpendicular grain, not only the grain, okay, it still have some cellulose of the timber cellulose. What is cellulose? C-E-L-L-U-L-O-S-E. Also helping to taking care of the force. So it have larger deformation. So this kind of behavior is similar to ductile material. Okay, again, we use the proportional limit as the elastic strength of timber. Timber have no yielding. Coming into this mechanical property, this come from in Thailand. This come from the Engineering Institute of Thailand. This come from what we have from the EIT. EIT. That is going to be Engineering Institute of Thailand. Okay, this table come from them, and we can see we separate the beam in the timber into 1, 2, 3, 4, and 5. Since they are in Thai, I didn't translate yet. Let us consider this. This is kind of hardwood. Okay, let's say it's hard timber or hardwood. Okay, this is going to be medium wood. and this is going to be soft wood, and the last one is very soft wood. Okay, and this is going to be the last one, going to be very hard wood. Okay, the tech T-E-A-K, the tech T-E-A-K. Okay, and this is very good wood that people use in Thailand, and this one also very important in Thailand. But anyway, the point is this: we like to compare what is the strength. This one is the allowable fractional, okay, strength, ENGTH, okay, is in kilonewton per square meter. For the wood, for the hardwood like the teak, we have the allowable of 120 kilonewton per square centimeter. For the steel has the yielding of 2,400 KSC, and then when it divided by 2, the strength of this is gonna be 1,200 KSC. And then you should compare it with the specific gravity. This is going to be specific. Okay, that is the ratio of the density of the wood with the water. Okay, specific density. Okay, specific density, and then you divide it. This wood has a specific density about 1. That is equal to the water. Okay, so the ratio of the strength to the weight per se going to be 120, and the ratio of the strength of the steel divided by the specific density or the weight, that is going to be 7.8 times the water. It's going to be 153. What showing here is when we compare the ratio of the allowable fractional stress with some specific gravity of the timber, we can see the timber is very strong. Okay, the timber is very strong. Timber is not just soft. Timber is very strong material, even though it is just a natural material. Okay, that have high strength to weight ratio per se. The tensile strength of timber. We didn't use much timber in taking the tension because when the timber subjected to most of the force like this one, okay, this force will separate into 2 parts. One going to be in compression like this, another one going to be in this. For this one, is going to produce the shear, okay, produce the shear here. But for this one, this another one is going to produce the compression. So most of the time the timber, they take the compression and take the shear, not taking the tension. No tension most of the time, even though for this one, let me have, even though for this one is 5 kilonewton. Okay, 5 kilonewton will produce the tension for this. Okay, but for this, but actually when this one fail, it didn't fail by the tension in the red line area. Okay, in the real application of this 5 kilonewton, the steel rod gonna take the force, and also the steel rod will transfer the force here. And what happened is this one gonna produce the failure along this portion. And if you consider the free body diagram of this portion, you may see that this portion of timber will fail by this one. This one is a shear, right? So most of the time, even the timber have tensile strength. Okay, larger than the compressive strength, larger than the shear strength. But due to the limitation of the construction of the tension joint, the timber is usually support compression and shear in the structure. And that's why I just mentioned before, the test that we have for the timber, this involve compression, is involve fracture and involve shear, because the application of timber is like that. Okay. And tensile force again for the perpendicular direction. When it's perpendicular direction like this, okay, it's going to open the wood. So when it's subjected to the force perpendicular to the timber grain, the strength of the timber in this direction is only 1/10 of the strength of timber in parallel direction. Okay, but anyway, we didn't use it much because when the structure is in tension or compression, it's fail by compression and it may fail by shear. Okay, this is important. The compressive strength of timber that we have in our lab 6 about that. The compressive strength acts parallel to the timber grain. What happened when it acts parallel to the timber grain? All the timber grain will work together to resist the force. And the failure like this is kind of the abrupt failure because it's caused by the buckling of the timber grain, and it have the crack in the pink line like this. Okay, you have high strength, sure, but it's brittle. But when it's going to have the compression in the direction that's perpendicular to the grain like this, what happened is the timber tissue and the timber grain, the timber cellulose, they are working together to resist the force. The compressive strength in this direction is going to be less than this direction in 3 to 4 times, but the failure of this is in progressive mode of failure. This one you may find in the column. Okay, but this one you may find it, like I said, is a supporting system for the railway, for the train, for the crane rail. It's going to be kind of supporting, okay, supporting member for like a train or crane rail. Okay, train rail. That's going to supporting for that. And for fractional tests, we also do it. In the fractional test of timber, we have I'm not sure what kind of number of the lab, but we have it. And we determine the compressive strength of timber. This time is parallel to grain. Okay, we also find the shear strength of the timber. That is also parallel to grain. When the beam is long enough, with the depth, with the span to depth is larger than 10, or with the L is larger than 10 times of the depth. Okay, the beam usually will fail in compression or in tension. This is going to be in compression. This one is going to be in tension, and we have failure like this in our lab. Okay, and when the beam have span to depth ratio, this is going to be less than, this is going to be less than 10. That is L over D, less than 10, or L is less than 10D. That's for the short beam. That is going to be for the short beam. The failure of the beam may occur like this due to the shear stress. Okay, shear stress at the end of this one, because by 3-point loading, you will get this one. If this P, this is going to be P over 2, and this is going to be P over 2. And then you have, the shear diagram of this is going to be like this. So this is going to be the Vmax. Okay, this is going to be the Vmax. So the Vmax cause the tau max here. If this tau max is larger than the strength of the material, so it may cause the shear failure at the top. But most of the time we didn't see that because the grain of the timber is not close to what we have in the theory. So sometimes we have the failure of the shot beam like this due to the tension. Okay, high stiffness timber, usually the timber with high stiffness, it could have high strength, usually have high strength because they have higher grain and fiber, and usually is going to be higher specific gravity, or it's going to be heavier. This one usually going to be heavier. Okay, it's going to be heavier than typical timber because it has a lot of grain. The factor that govern the strength and stiffness of timber, there are a lot of strength of factor. The first one is the type of timber that we take a look at the timber before. That's from the EAT 1002. Okay, classify the timber into 5 types as I mentioned before. Okay, and this is the one that we have, and I'm trying to change some in English. It's going to be this one for the modulus of elasticity. This one for, no, this one is not modulus. Okay, this also the modulus of elasticity, but this one from okay, this one from parallel to gain. Okay, this one is the modulus of elasticity, but this one from the fractional test. This is for the fractional test. Okay, this two is for fractional test, and this maybe come from the tension test. Okay, that is tension. This is tension, and parallel to grain, Okay, and moisture content. If you consider the graph, okay, this is strength of the timber and this is moisture content. You may see that for the compression parallel to the grain, the strength when the timber is really dry, have zero moisture content, it's going to be 68, and then it's due to 55 when the moisture is 5%, and it's due to 42 if the moisture is 10%, and it's going to be 27. That is going to be half of the original strength here. That's when the timber have the moisture of 15%, and then it will reach this fiber saturation point. That is about 27%. Okay, that is the way that fresh wood or fresh timber have the moisture content. Okay, it's going to be some, can be up to 30%. But anyway, we should not use very wet or very high moisture content material, because when it's high, when the moisture is high, the cellulose and lignin the grain is going to be softened and the strength of timber get lower. So you got to do very careful with this one. Fresh timber has 35 to 55% moisture content, as I mentioned before, and you should to reduce that moisture by room drying. Just left the timber at room temperature for like 2 weeks or 3 weeks. The moisture in the timber will reduce a lot. Okay, and then the strength of that timber can get higher. And you also can test for the moisture content by cutting the specimen to be like this. This is going to be just 25, 25, and 50. This is 50 millimeter. This is 25. This is 25. And you put into the oven, okay, for 101 to 105 degrees Celsius for 24 hours, the moisture will evaporate from the timber, and then you can find the moisture content. You just put the water. For example, if this one have the weight of 100 gram, and then for 24 hours, the weight is going to be 90 gram. So the percent moisture content can be like 90 minus 100, and then divide 100, and you times it by 100%. You can get this easily, right? That's the moisture content that evaporates from the timber. Timber shrink a lot when it's lost moisture, so you got to control it also. More loss in moisture is going to shrink, okay, and sometimes it's also twist due to the moisture shrink. So you got to have some control on ornament. Timber is no good if you put into the outdoor structure. You got to make it stable before you use it outside. Okay. Next, specific gravity. High specific gravity. That means you're going to get a lot of grain. You got to get also road. Okay. When you got a grain out of the road, what you have is you get higher strength and also higher stiffness, because of the grain can take a lot of force, and it's also make it more stiff. Cellulose timber usually have equal 1.5%. Have equal specific gravity for 1.5. That's 1.5 times the water. However, different timber have different amount of cellulose. Okay, that means when have different the grain pattern also, when it have a different of that. So finally, the timber have different specific gravity. Since the arrangement and the grain are different. Okay, and the construct timber usually have the specific gravity of 0.7 to 1.1, or density of 700 kilometer per cubic meter to 1,100. Okay, if this is going to float on the water. Okay, this one is going to sink into the water. This one going to float on the water. So depend on what we have. The duration of the applied force. If the force applied to the timber for a long time, it may cause the creep, okay, of the timber. And also the author is the size, the location of the defect that we have. Because when the timber have defect, the defect is going to be the weak point. Okay, weak point. And it's going to be the starting point of failure of the timber structure. Next is the size of the timber in construction. There is two ways when we sizing the timber. It's a normal size. When you buy the timber, we buy by nominal size. Okay, it's the size the sell in the market. It is smaller than the actual size. It is smaller than the actual size due to the loss in cuts as moisture content. Okay, so when you buy the timber, you will get smaller dimension due to this. Actual size is going to be smaller than the nominal size. Okay, and then for the timber as large as 150 millimeter or 6 inch, you may lose the size of 9 millimeter. And if it's big like 200 millimeter, you may lose the size of 13 millimeter. That is allowable. That is common in the market. Okay, and if you cut the wood, like I said, it depends on how you cut the wood. If you cut it like this, it's going to be the post or the column. And if you cut it like this, it's going to be the beam. And if you cut like this, it's going to be the plank. That's for the floor of the structure. That is rectangular section timber. Okay, the thickness about an inch. Okay, it's maybe half inch, 3/4 inch, or 1 inch. This is for the floor of the structure. And the width may be 2 inch, 4 inch, 6 inch, or 8 inch. This is going to be the width this is going to be the thickness of the plank. Okay, the post, like I said, the post, if you won't cut it, the section going to be the post, that's going to be the column of oh, sorry, I mispointed. Okay, this take it off. Okay, you will get this is the section of the post. It can be rectangular section. Okay, and it can be square section. The size can be 2 inch by 2 inch. This is the size very small. This is 2 inch by 2 inch. This is going to be 3 inch by 3 inch, and it's going to be very large, 8 inches by 8 inches. This is going to be very hard to find and very expensive. And for the small one, it can be found easily, right? Because it didn't take years to going up the tree as big like this. And you can do the gulam, okay, the gulam. That's going to build this big section of the post. For the beam, as I said, you cut this one, you get this one, you may cut this as the two beam. Okay, the beam going to get bigger width. It's not just 1 inch at the plank, but it's going to be 1.5 or 2, and its depth actually is this one supposed to be depth. Okay, can be 3 inch, 4 inch, 6 inch, 8 inch. Okay, that is going to be the size of the timber. Next, in the past we used the timber as the formwork and the basing. Okay, and basing. And then when you see this, you try to build the beam here, you got to put, usually it's the eucalyptus. Okay, and it's have the supports like this, and it's going to have like this. In Thailand we call it tukta. Okay, it's the post, it's the form work post. This is form work post. Okay, in our Thai style we call this as the tukta. And then you put this one up, and then you lay this one, the plank. Okay, and then you're putting the reinforcement into the position. After you clean everything up, you put the size of the formwork, and you tighten it up. You pour the concrete. Okay, that is going to be what we have to show here. This is the eucalyptus, and this is the cross beam, and this is the bracing. Okay, and it isn't used much nowadays. Most of the formwork and bracing now made by the steel. Okay, there are some standard. Sorry, this is going to be the standard. I didn't change it yet. Okay, this is going to be that we have testing standard. It's a test standard. You may follow the TAS 421 for the saw timber, 424 saw timber as the structural timber. This is general timber. Okay, and you may follow the DPT or Moyopol for some of the testing for the EAT. We don't have much standard for this. The big standard is here, these two. That's for the industrial particle board. Okay, there are a lot of companies in Thailand produce the particle board, such as for the Siam Cement Group. And we also have the STM standard showing here. The mechanical property that we are going to test is going to have 4 of them. These 2 come from our one lab. This is for the compression test of the timber parallel to grain, and another one actually we test this in perpendicular to grain. This is going to be perpendicular to grain. This is going to be for parallel to grain. This is perpendicular to grain. Okay, and we also do the fractional test. And then we obtain what? Modulus of rupture. Actually, this one also provide the modulus of elasticity parallel to grain also. And the last one, we do the single shear test of the timber. Timber is like this, okay, and then you push it. It's going to have the failure crack along this. The advantage and disadvantage of using timber in construction. Advantage. For sure, timber is going to be very beautiful, very aesthetics. Okay, only aesthetics is very beautiful and is environmental friendly because it's a natural material. It's come from the forest. It can be construction easily and can be reused. Nowadays, there is some old house that some people buy it and take it from somewhere to somewhere, like the one in Phetchaburi. There are a lot of old style house, and since the maintenance cost of old Thai house is very expensive, so the owner of that house, after their ancestor passed away, they sell the old Thai house to some rich people. Okay, and it can be rebuilt to a new house. I have one in my hometown that's belong to my grandmom, grandpa. That's 100-year-old house. It's made by golden sap. Okay, and people coming and asking to buy it for like a 2 million baht. My mom and dad, he and she, they don't like to sell it, and they spend a lot of money to maintain its condition, because of most of the time it's very susceptible to weathering. It's also there is some bad insect that eat those kind of wood, okay, and destroy it. One time the insect eat one of the column. We need to cut it and burn it and buy a new column to strengthening it. And next is high strength to weight ratio. It's comparable to the steel. If you remember, we have the 120 divided by 1. Another one is 1200 divided by 7.8. This is 150 something. This is going to be 120. That's kind of comparable. It is a good heat insulation, okay, because the nature of timber is would take the heat like the steel. It's neutral for the heat, and it's really durable if you have a good design, good construction, and good maintenance. Like I told you, I have a old Thai house belong to my grandma and dad. That is 100-year-old house, but the maintenance of that house really delicate and takes a lot of time to do so. So who own Thai house, okay, who own the wood house, if you like it to be long lasting, you got to pay a lot of attention. You got to pay a lot of attention to that structure. The disadvantage is come from, that's for the disadvantage. Okay, the mechanical property is uncertain. It depends on the type of the wood, the where it's go. Okay, for example, if you talking about the teak, you know the teak, right? Teak, T-E-A-K. The one that go in the northeastern part of Thailand, which has less water compared to the one that go in the south. The teak in the south go very fast. The teak in the northeastern part of Thailand go very slow. But since it go fast, okay, the grain and the lignin and the layer of the teak in the south is that's no good compared to the one in the northeastern part of Thailand. When they build a house or they build a boat, they prefer to have the teak from northeastern part of Thailand more than those in the south. It's sensitive to environment change, like I said. Okay, when it's change in temperature, it change in humidity, the timber can twist, can bend, and also the strength and the stiffness of timber can be decreased. So you got to protect it. You have to paint it. Okay, you got to put some special additive to the timber to maintain it in condition. Also to maintain it from the insect. And it have creep behavior if it's subject to large load and long duration. It's going to have the permanent deformation, and that's going to make it not beautiful. It's not durable. It requires good maintenance. That's to mean it's going to take uh, cost to do so and the labor to do so also. Okay, that is the end of what we have for the timber. And in short, timber may be luxury thing. Okay, if you prefer, you may in the future have your own commercial forest, have your own timber industry. You got to study how to grow the timber. You got to study how to cut, how to machining the timber, how to treat the timber with a good killing. Also, you got to learn how to use the chemical agent to protect the timber from the insects. And you can use the concept of glued lumber or bolted lumber to make small piece of lumber to be the bigger parts. There is an alumni of our civil engineering. He is a factory in Suranaree. He also working on this uh, industrial timber and send or export those out to foreign country. Okay, that is the end of the timber. I hope you get some idea and you may use this when time to come. Okay, that is the end of the clips. Bye bye.